Welcome to part 2 here of this repair series of 6 chassis, which is actually I think video number 2 here now on the new channel. And what we have is a Wells Gardner K7400, and it appears to be complete from initial glance. Let's go over what is wrong with it here. It says replaced B+. I don't know what that means. B+ pot, B+ cap. I don't know what replaced B+ means. Cap kit done, just does not power up. Sections of it are getting very hot. I just don't have enough knowledge to figure it out. Okay, so let's see if we can figure it out. Let's set this aside and we'll give it a look over. This is one of the very late models of K7400 that has the newer style of heatsink and the newer color transistor. But looking at it here, this appears to be complete. I don't see any broken filter caps, which are common. All of our neck pots seem okay, nothing broken on those. We'll spread out our resistors here. Alright. Neckboard transistors seem fairly secure, but we're going to have to cut this off and get a better look. And yeah, this looks really good. There's no lifted traces. It's not burned at all. This is basically brand new. A lot of that probably, it could not be new. It could be a fairly decent usage, but because of the better style heat sinks, it simply didn't burn up the board or the traces. But you can see the very common issue of burnt traces and pads here is not present, so that's a good sign. Actually, we don't even really need to do any reflow. The solder joints look really good as it is. Everything on here looks pretty good. Normally I reflow the header pins for the ribbon cable, but that looks pretty good too. This all looks pretty darn good. I don't really see anything that needs to be done on the neck board. So hopefully we can call this okay. Yeah, I would say the neck board is in pretty good shape. So whatever issue this has, it most likely isn't due to the neck board. So let's go back to the main chassis here, and as we can see, a new flyback has been installed, and this is the kind with the dual focus, but I believe it's one of these two. This top one doesn't do anything. You'll see there's only one focus wire coming out of it. You've got the G2 wire. The one that comes out of the bottom is always the G2 wire. Now some of these flybacks on other versions of chassis have 2 wires coming out the top or 2 wires coming out of the bottom. So on this style, where one comes out top, one comes out the bottom one is always the G2 and the top one is always the focus. Now if you have one where 2 come out the bottom or 2 come out the top, the skinny one, one's a skinny one, one's a fat one, so disregard the colors. The skinnier of the two is always G2 and the fat one's always the focus. Then of course the anode should always be self-explanatory as the biggest of the 3. But the skinny one's always G2 regardless of where it comes out, and the fat one is always the focus regardless of where it comes out, just so you know. I say always. There may be an oddball out there, but 99% of them are like that. So then we got new caps obviously as well, just like the note said. So let's get all of this out of the way. I'm going to disconnect the remote board here so it can be out of the way, and our other neck board ribbon cable. Okay. Well, typical bent resistors, and K703 seems alright. This is the power transistor, where if this is broken or missing or bad or shorted or open or what have you, it'll be completely dead. 100% dead. So it very well likely, if this is in fact dead, we could have a bad K703. So we'll get to that in a moment. But looking at it as a cursory glance, the B+ pot is original and still has the glue, so whatever replaced B+ means, that was not the answer. Somebody has done something here on this diode in the rectifier circuit. Someone has globbed a bunch of stuff here. Solder globbed it all on, just on these two for some reason. Not this one or this one. Not sure what's up with that. Yeah, just looking it over, it seems like there's nothing missing or broken. Yep, okay, well, let's start probing around, see what we can find out. There's no reason to even try to power it up first because of what the note said. Now, knowing that if Q703 is bad, the chassis will be dead, and you know the note says right here, just does not power up. Sections get hot, so with it not powering up, I don't know, it doesn't say anything about ticking, which is usually a sign of the HOT being blown. But we'll test Q703 first, this guy here, and we'll see what it reads. If it reads bad, then we will continue on with our testing and replace it, and if everything else tests good, then we will fire it up and see what happens. But we'll get our meter set up. And Q703 are these three pads here. There's our base, and like I say, because this is amateur hour, we don't know. I don't know if it's base emitter collector or base collector emitter, but we should be able to put our meter lead on the base and go to one of the other two pins, 0.6 and point. That doesn't seem right. Let's swap these around here. Well, it's not shorted and it's not open, but that doesn't seem like a good reading. That's a good read. That's the diode inside the transistor, so that's good. Now the other side, well, we'll go with that for now. I can't recall offhand if that's good or not, but it's not shorted and it's not open, so we'll consider it okay for the time being. So with Q703 out of the realm here, out of the realm of possible issues, for the most part, I don't suspect it anymore. We can test our power circuit. Again, there's an easy test that you can do. This resistor here, R104, should be 10K, as we can see. Now, if you read this and it doesn't read 10K, then there's something here in this power circuit that's shorted or bad. If you do read 10K, then you can pretty much eliminate everything in this area, because everything in this area is going through this as part of the circuit. So if we actually test this, if we get 10K, 9.98. So that test right there can pretty much eliminate all of this stuff here. Because like I say, if you had a bad capacitor here, or a bad coil, inductor, or a bad C106, or bad voltage regulator, or bad resistors in here, or bad filter cap, this would not read 10K. Just from my experience, I can tell you that. So this is a very easy, quick test you can do to test all this stuff here. This is 10K, we're good to go. So next, this here is our voltage regulator. It's Q101. So we can test our voltage regulator. It's just like any other transistor. It is these three pads here, this triangle, 1, 2, 3, or 1, 2, 3, this triangle right there. So we'll put our negative on the base and we'll touch our two leads here, 0.5 and 1.0. So that pretty much reads just like our Q703. So our voltage regulator should be good. Then we have our switch mode power supply chip, this little IC right here. It's U101. If this switch mode power supply chip is faulty, then it won't power up either. You won't have any B+. So we can test this. You want to leave it on your diode checker. And I believe it's negative. You want to test these two pins should be a diode. These two pins should be a diode. These two pins should be a diode. And these two should read 1.0. Or there should be some... I don't have it memorized. I should, I guess. But this is what we'll do. Is we'll test these two pins like this. There's our diode. These two should be the same. Yep. I think these two should be the same. No, there's our 1.0. And this other set should be a diode as well. No, 1.9, I think. Okay. Well, either way, if I recall, that's actually correct. We get diode, diode. I knew one of them was 1.0, which ends up being these two here. And then 1.7 or 9. Yeah, I think that's okay. So our switch mode power supply chip is good. So we've eliminated the problem over here. Our switch mode power supply chip is good. K7400 is good. So let's test our HOT now. And just like the rest of them, it is this triangle here. 1, 2, 3, 1, 2, 3, this triangle. So we'll go negative on the base. If I can do this where you see here. Nope, let's just do this way. Alright. And Q's, yep, 0.5 and 0.5. HOT is good. So that's alright. Now, with the HOT being good, that will eliminate these polycaps here, because these polycaps can short. These polycaps can short and cause the HOT to blow or not power up. But if the HOT reads good, then these polycaps here are all good. This one, this one, and this one. So we can eliminate those as being a factor if the HOT reads good. But we can also test these other transistors here. Let's see, it's D707 is basically just a diode in an IC form. And then we have, what was the other one? Q710, which is another transistor here. We can test those. So we know that is, these two legs here are that diode. That's good. And here's our other transistor, 0.5 and 0.6. That's good. Well, I don't see anything initially that would keep it from powering up. Let's look at the backside for bad traces or anything. So I guess since everything tests good, I mean it could be a bad U701, but I don't think so. U701 is usually has to do with your vertical section here and not power issue, so to speak. I guess we can always check the fuse, but I can say in 16 years of working on arcade games, I have never seen a 7400, 7500, U2000, U5000. I've never seen one blow a fuse. Never. This thing will catch fire and explode before the fuse goes out, so I don't even know what the purpose of the fuse even is. But let's take this cover off here, and we'll go to... Yep, so like I say, I've never seen the fuse blow on these ever. I've seen them catch fire, burn a big hole in the middle of it, and the fuse is still good. So I don't even know what the purpose of the fuse is in the circuit. Obviously I know what the purpose is, but it doesn't do anything. It doesn't provide circuit protection because it has all kinds of problems without the fuse blowing. So, alright, well, let's inspect it and see if we can see anything visually, because everything checks good. Maybe they just weren't hooking it up right. Sometimes the sockets on the power connector can be bad, but these look good. They're not spread open. Sometimes these can be spread open from someone sticking a probe in there or doing something, but these all look pretty good. They're nice and closed. The other side, we have broken solder. Nope, solder joints look good. Not cracked or anything. So let's take another look here at the bottom side. No, I don't see anything offhand. So it's odd it wouldn't power up with everything testing good. There's a bunch of here, get that off of there. Well, okay, let's hook it all back up and get it on a tube and see if it works. Okay, remote board. All right. Stand by, we'll get it hooked up and we'll see what happens. All right, we got everything hooked up. Anode, neck, yoke, ground, and video. And remote board is number 6. So let's see what happens. I'll get it on the tripod and we'll fire it up. Any bets? And here we go. Came right on. We're not counting our stars yet, but I bet you the flyback is turned all the way down just like the last one. Yeah, there's no video yet, so we'll do the same procedure. Brightness all the way down, contrast all the way down. We'll turn up our flyback. If I can. It's not letting me. Hold on. Let's do it on this side here. Hey, look at that. Turn it back down to roughly there. Brightness, contrast. Have to fix our focus here. I got no focus. Oh, it's the top one. There we go. Okay, so I misspoke earlier. There's 3 knobs on the flyback. The bottom one is the screen pot. The middle one says focus, but it doesn't do anything. The top one doesn't say anything, and that's the focus. So anyway, but there, I mean, that's a sharp picture, if I do say so myself. The colors are a bit off, but again, I'm not really too worried about colors because this is not staying on this tube. But I'll say that looks pretty good. A little bit more red. Boom. Let's see, it's kind of cut off on the side, but it's still equidistant. So I'll bet you if we simply just adjust our width here, H position, vertical size to roughly there. V position. Well, that looks pretty darn good right there, boys and girls. Obviously, the person that had this before did a good job with the soldering and the cap kit and the flyback. I mean, I'm rather impressed with their ability of being able to do all that. But just like they said, they don't really know where to go from that point. They can do all the type of work, but when it comes to troubleshooting, they're a bit behind the 8 ball. But I'm a little bit mystified as to why they had a problem, because the note says, just does not power up. Sections of it get very hot. Well, it's working fine for me. Sometimes you get lucky like this and there's nothing wrong. It's what's known as operator error. So I don't know if their tube could be bad, their yoke could be shorted, but if the yoke is shorted, usually it'll damage something on the chassis. But if the yoke is shorted, or the tube is bad, or they didn't have it hooked up right, or they didn't have power getting to the chassis, which I don't think so because they said stuff was getting hot. I don't know. I can't say. But yeah, it's working fine for me. Nothing was wrong with it. So I'll get it back to the owner, and we'll move on to chassis number 3, which is going to be a K7500. That'll be a whole nother fun adventure. Hopefully it gives me the same lack of grief as this one, but I don't think so. I'm saving I got a G07 down here with a giant crack in the board. I'm saving that for last because that'll take the most time. And I'm waiting for my new fiberglass scratch pinch to come in because I'll have to be doing a lot of trace repair on that. So stay tuned for that. That'll be fun. But yeah, here you go. K7400 working just fine. The previous work was done very well. I don't know why they were having power issues because it works fine for me. So I'll tell the owner, you know, check A, check B, check C, because it works fine for me. So thanks for watching, and stay tuned for the next video in the series and for more arcade repair and good content. And thanks for watching. And like and subscribe if you haven't already done so. I appreciate it.